Hey, we're going to talk about the distance on the real number line. So let me sketch out the real number line. Now this idea of distance is pretty important in calculus, and you'll see that and hopefully make those connections as we go along in calculus. And of course, right off the bat, you're going to see that when we just start dealing with a limit. Let's make this the origin here. Okay, distance, and how do we define it? Well, the distance between 2 points A and B. So let's just label this A, and I'll label this point on the real number line B. And we want to find the distance between A and B. And this distance is given by, so we'll let D equal distance, the absolute value of A minus B. A minus B. Okay, so why do we use the absolute value bars? Well, let's look at an example here. Let's say that this happens to be a -7, and we'll say that this is -3 here, or +3, sorry. We'll make that +3b. And so let's say I don't use the absolute value bars. If A is -7 and B is 3, then what do we get? We get -10. And distance, when we're just talking about distance, distance needs to be a positive number. Okay, when we're talking about distance, right, the distance from point A to point B, we need to be talking about a positive number. So what we want to do here is make it absolute, and therefore the distance is 10 units. This could be 10 miles, 10 inches, 10 centimeters, right, 10 kilometers, but we're just generally speaking units here, so we'll just say 10 units. Now, if we want to find a direction called the directed distance from, let's say, A to B, this is what we do. Let me sketch out the number line again. So we're talking about the directed distance now. So let's say, for example, I pick a point here. We'll call this A, and this point B, and we want to know the distance between A and B. What we're going to do is since B is to the far to the right, we're going to say B minus A. B minus A. Okay, and of course if we do B minus A, we should get a positive number. And basically what this means is this is the directed distance from A to B, the directed distance from A to B. And the other possibility, we've got one other possibility here, and I bet you can guess what it is. So we're going to label this A and this B. Now, we want to find the directed distance from B to A. The directed distance from B to A. And so what we do here is we say A minus B. the directed distance. Let's give an example here. Let's say that this happens to be -1 and this happens to be 5. So if I said 5, or sorry, if I said -1 minus 5, we end up with a -6, and that means we're going back in the negative direction, right? If up here we said that this was -1, let's look at the top one up here. So this is -1 and this is 5. Then this would end up being 5 minus a -1, and so we would end up getting a +6, and that tells us, right, that our arrow is pointing to the right. And that would, in the first one here, okay, this is the directed distance from A to B, and then the bottom one is the directed distance from B to A, and of course they're differing by their signs. And this could be important in a number of different areas. Usually velocity, if it's negative, that means that the ball is falling. And if it's positive, it's going upward. So this idea of our distance being negative or positive is pretty important. It tells us the direction that we're heading. Okay.